time for some fun and games. As I indicated earlier, complex numbers are just numbers, and you can do addition and multiplication and those sort of simple functions with them, but you can also do trig functions and exponential functions and all those sort of things. So we have here some basic relationships with cosines and sines and coshs and shines, which relate complex numbers. So z in each of these things is a complex number. J is just the square root of -1, that's our introductory number there. And I'm going to try and just do one example. I'm going to try and evaluate the sign of 1 plus j. So what I've done is use the equation here, and instead of z, I've replaced it with 1 plus j. So z 1 plus j, z 1 plus j. And I'm going to have a go at sorting this out, and hopefully at the end of it, end up with a complex number. So a real part and an imaginary part. And there's quite a few little tricks involved in this. So down the side here, as we go along, I'll need to come up with some other relationships, which are things you've probably seen before, but we just need to be able to deal with those. I mean, the first one is e to the j theta is cos theta plus j sine theta. Okay, so that's one of the relationships I'm going to need to use, and I'll come up with a few others as we go along. Okay, so let's have a go at trying to figure out what the answer to this thing is a single complex number. So let's make sure I've got some space, so we'll go over here. Okay, so the first thing I'm going to do is expand these brackets. I'm going to end up with, leave the bit out the front, so e over j2 or 2j, it doesn't make much difference, and then brackets. Okay, so this is e to the power of j plus e to the power of j squared, and e to the power of two things added is the same as e to the power of one of them times e to the power of the other one of them. So that's going to be the same as e to the power of j times e to the power of j squared, which is -1, minus e to the power again, -j times e to the power of -j squared, which is -1 is +1. So we end up with that expression there. And then I'm going to use the j exponential form form of complex numbers for this one. So effectively theta is equal to 1. So this is e to the 1 times j. So if I use this with theta equals 1, I can get this out of the exponential form. I can get that j out of the exponent. So 1 over 2j, and then instead of e to the power of j, I'm going to write cos of 1 plus j sine of 1, e to the -1, minus cos of -1 plus j sine of -1, e to the power of 1. Okay, so I've now got that all written as a sines and cosines, but the key thing is I've managed to get the j out of the power. So it's starting to look like something which might be a little more usable. And what I want to do now is collect all the real terms and the imaginary terms. Let's move up the page a bit. Okay, so what I'm going to do now is I'll leave that 1 over 2j for the meantime. I'll deal with it shortly. And then in my brackets, some of these are real terms and some of them are imaginary terms. So for example, cos of 1 times e to the -1 is a real number. There's no j components in that one. So that's going to be e to the -1 cos of 1. And over here, minus e to the power of 1 cos of -1. And this is where another useful thing, just to get rid of the stupid negative in here, cos of -x is the same as cos of x. Okay, if you draw yourself a quick sketch of a cosine function, you'll be able to convince yourself of that reasonably quickly. So this is just the same as cos of 1, so it's going to be minus e to the power of 1 cos of 1, e to the power of 1 cos of 1. And then I want to just have a j component, so plus j lots of whatever's left. So the j ones is sine 1 e to the -1, so e to the -1 sine 1. And then over here, I'm going to do the same thing with this negative sign, but for sine it's slightly different. Sine of -x is the same as negative sine of x. So this is the same as negative sine of x. So that minus is going to make it altogether plus. I'm going to have plus e to the power of 1 sine of 1. Shut that bracket and shut the big square bracket. Rightio, so I'm getting somewhere. I've at least got something which is sorted out. I could factor a cos 1 out of these guys and a sine 1 out of those guys. And I've got a real part and an imaginary part. And the only drama that's left is I've got this divided by j out the front of it. But, again, the last little trick I need is that 1 over j, if I multiply the top and the bottom by j, is the same as j over j squared. And j squared is equal to negative 1, so it's just negative j. So this whole thing is the same as negative j. So if I multiply through this thing by negative j, I'll have the same answer. So let's just try and finish everything off now. So this negative j times j will give me minus j squared, which is the same as negative 1. So I can bring that as will be a real term. So I can bring this all out the front, and I'll factor this sine to the power of 1 out the front of it as well. So I get sine 1, and then I'm left with e to the power of minus 1. I'll do the e to the power of 1 first, plus e to the power of minus 1, all over 2. Times in there. Okay, so that's now a completely real number, and then I'm going to have an imaginary number from this piece here. So again, bringing that j, negative j I'm going to introduce into here, will make this thing change signs. So I'm going to end up with a cos. I can factor the cos out the front, and then I'm going to be left with e to the power of 1 minus e to the power of minus 1, and again, because of 2, it's all going to be over 2. Okay, so I now have a real part and an imaginary part sorted out in terms of it's a real complex number. So I've taken what was the sign of a complex number and I've turned it into a complex number, except that in the process I've managed to forget the j there, okay, because that was the real part multiplied by j made it a negative part. So definitely a lot of jiggery pokery, a lot of mucking around with some really quite interesting little relationships which I've had to incorporate to get through the process of doing that. And not something you're going to have to do particularly often, I wouldn't imagine, but it's worth having seen the fact that you can change a complex number, you can do the sign of it, and it just comes out as a complex number.